Good afternoon, everybody, or good morning if you're in the Western Hemisphere. My name's Jason Fox. I'll be hosting the next 3 hours of FIWARE training. If that's not enough for you, I can. Where's the Q&A disappeared to? You can contact me directly as well. So I'll just put this in here. Would I like to share? That's my LinkedIn details. What we're going to be covering today is basically in two halves. So after I've done this session, there will be a short break whilst I drink a cup of tea. Yes, I am English. And then I'll continue talking on for another hour and a half afterwards. It should be clear that so far we've already discussed what context brokers do basically. And that is all your standard CRUD operations plus registrations plus subscriptions. So it's assumed that you understand what that's all about. What I'm going to be covering today is all the other things which context brokers are capable of doing. So this is the more advanced stuff, which assumes you know what you're talking about. Now, the first section I'm going to cover is stuff which is rather experimental, as the title of the slide mentions. It's advanced and experimental features in Orion-LD only. However, if you look at the latest draft for comment from the NGSI-LD ETSI specification, they've got this sort of thing in there. So it's 98% that this will be it. I know, for example, some of the syntax is still up in the air, but it's all useful stuff. So where things are more experimental, I will try and explain what's going on. Right. So one of the things which is potentially being added in to the NGSI-LD 161 specification, which is, I believe, formally due out September, October, probably about the time of the FIWARE Summit, is to introduce or rather formalize a new concise format for your NGSI-LD payloads. There is an impression which, again, I tend to give myself during the introduction stuff, that in order to get an NGSI-LD payload, you must have properties or relationships, and they always have type property and a value, or type relationship and a value. But actually, if you look in more detail, this is not really the case, and it never really was the case. It's just that that more verbose normalized format is what you would expect for things like data exchange. It is absolutely, as normalized means, it's absolutely fully understandable, fully comprehensible, leaves no margin for doubt about what's going on. But developers are lazy. We don't need to do the formal stuff all the time if it's easier for us. So the introduction of a concise format is primarily to introduce a new input format, or a simplified input format, so that users can update their data. Important points are, of course, that every single NGSI-LD payload must be a JSON LD document. There's no arguments about that. It must remain compatible. It is obviously must be able to do all the operations which were covered previously, and it must be lossless. Now, if you look at the older NGSI v2 format, which is JSON-based rather than JSON LD-based, there are certain endpoints where you can actually just put in values. Just put in, I want to update my temperature attribute to 6. And there needs to be something similar to that, but it must be done via a JSON LD document. And it won't be difficult to understand how concise works. On the top left-hand side, you've got a a temperature attribute with your property type and value, and all that needs to be done really is that, well, you don't. If you've got a value, you don't really need type equals property anymore. It's kind of implied. So just temperature value. That's it. It's going to be a property. But actually, it's even better than that. But specifically for properties, you could even say, well, actually, value is implied. So we can just go temperature equals 100. Now, what you've lost here, if you go for the super concise property, is you can't put sub-attributes in the same payload, obviously. But in some cases, that's not what's required. All you just need to do is to update the value. Now, if you remember when I was introducing JSON-LD, it was standard JSON-LD document, just key value pairs. Well, this is just key value pairs. It's nothing particularly impressive. It's much easier, but it can be used as both an input and output format going forward, or at least will be formalized to be to do so. There is a similar example with geoproperties. Geoproperties obviously need to be in the format of GeoJSON. And a GeoJSON value will always have internally a GeoJSON type, which is going to be point, line, string, polygon, multi-polygon, etc., etc. So because you know that the value within the value there's a type, and the type has got a valid GeoJSON type, well, that is can be done as shorthand for a geoproperty. So you just put in the value. You don't need to put in the type of geoproperty, and it's fine. And even better, you can do that just as well if you're not putting in metadata into the super concise format, which looks just like a key value pair. So this should be good news for everybody. Simplifies everything we want to do. It's not quite as easy with relationships or language maps. You can't reduce a provided by relationship down to just a key value pair, because the URN itself would then just be considered as a property rather than as a relationship. This is obviously going to be mean the object itself is mandatory. So for concise relationships, all you need to do is to make sure you've got the object. Obviously, if you had any properties of properties, same thing applies. Normalized language map is again, language map is mandatory when you are pushing the language map as a JSON object. A language map is a specialization of property where on the right hand side you could have a series of key value pairs, and the value of those is a string or strings in a natural language. So here you've got Constantinopolis in Greek, you've got Constantinople in English, and you've got Istanbul in Turkish, all refer to the same city. Now, language maps have this sort of dual nature in that you can request them back as ordinary properties, and you can see that it would come through as like an ordinary property if you were asking for particularly the English language name of the attribute. Once again, input and output formats for this system. Concise is going to be available on all the expected, CRUD rather than CRUD endpoints, in that you can, when you're doing a get, you can get as concise, which is basically going to get back as key value pairs, or going to get in as concise as possible. So if it's got metadata, it will need to have the second level, otherwise it'll just look like key value pairs. It'll look very much like simplified. If you want to do a create, obviously it's going to be post, and you can also do updates of get of specific entities query parameters or whatever, or get a specific attributes within the value. And obviously, there are the batch operations. A batch operation means you can operate on multiple entities at once, which is obviously, again, useful, upsert and delete, modify, etc., etc. Now, this is new context broker operations in Orion LD at the moment, but of course, this could be or will be slowly extended to other context brokers. The way that NGSI-LD, the NGSI-LD API is readily defined is that the various HTTP methods are used as you would expect them to be used, and this is what the values actually do. So get will get the entity, post patch and delete, fairly obvious. Put is going to be an overwrite rather than a partial modify. Now, options is available on Orion LD, but would not be specified as part of the API, because it's just saying what operations are actually available on each endpoint. Basically, the further you go down on this slide, the more esoteric things are. I don't think I've ever come across any API that offers trace. So funnily enough, NGSI-LD doesn't offer trace either. Head might be useful. The two new put operations are where you would expect them to be. You could either replace an entity or an entity attribute, and it's just an obliterate and overwrite. So you can just say, I have an existing entity with entity ID 1234. I now have a new entity with 1234, and it's got completely new attributes. The only caveat here is that technically put operations should be idempotent, and indeed, as regards the data in the payload, this isn't idempotent. It's just say, if I put the same payload put multiple times, it's going to update it with the same data each time. However, under the hood, if you use the sysactors query parameter, you can get a modified at system attribute. And obviously, this is updated whenever put is occurred. So it's a diversion from pure idempotency, but it's still necessary. Obviously, there already is an existing batch equivalent, which is just entity operations update, which again, update with the override option is going to give you a put equivalent. There will be one new patch endpoint, which is a merge patch as opposed to a partial update patch. I'll describe those in more details, and I'll show a demo in a second. But the interesting thing about this patch endpoint on a specific entity ID is that not only does it accept concise and normalized, but there's also a certain amount of support for key values updates. The reason why this could be done is because a merge patch is a forensic knife. It just updates the attributes you supply. So if you're just supplying part of a key values, that's effectively going back to what we were doing for the concise definitions. It's going to be just changing a single value. Because of the nature of the observed at property of a property, that can be updated in a common fashion. And it's also possible to update elements of a language map. So if you've got, if you just want to change the French language string or strings for a language map, it is possible to do it using the lang parameter. Now, going into more detail about how patch works, there are 3 endpoints which offer patch, and they all work slightly differently. So let's look into more detail. Imagine you've got an attribute, temperature attribute, with a type property, value 25, unit code Celsius, and an observed at date. Fine, it's beginning of January. Okay, if you use the attrs endpoint, the temperature will do an overwrite of that object. So you can see I used to have Celsius in there. I no longer have it because I'm not supplying it. This is very useful if you want to make sure that everything is highly consistent, because obviously if you fail to put an observed at in, it won't be part of our temporal series. You can see that unit code is missing. Now, this is the way that partial updates work, either partial update of entity or partial update of an attribute. And obviously, if you're doing attrs over temperature, you're not going to be changing another attribute like name. It's going to be left alone. It's only going to affect the stuff which is part of that payload. The difference between the attrs and the attrs/name of attribute is that in this particular case, you are just changing the values inside of the attribute in question. So here, once again, I'm not supplying unit code, but I'm not supplying unit code. It is unchanged and it remains. The way to work out what's happening here is that it's all a matter of what level are you supplying at. If you look at the first level attribute, that is the one which is doing the overwrite. So we're overwriting type, we're overwriting value, we're overwriting observed at in this particular case. In the previous slide, we're overwriting temperature because that's the element at the lowest level. So you can see here that the temperature sub-attributes are replaced in the payload contents when attrs is running with the attribute. The new version, the new endpoint, which is a merge patch rather than a partial update patch, is a question of doing a forensic knife. What you do is whatever you have supplied will be updated. Whatever you haven't supplied will not be updated. So again, what we've got here, we've got temperature just with property and just with value, and it will just be temperature, the type property and the type and the value, which will be overwritten. Now, it's generally excluded that you can change an object, a relationship to a property or vice versa. So the fact they've got type equals property in here is purely because I am showing this in normalized format. If I was showing this in concise format, it would just be the value. So that makes sense too. The values are merged. So in this case, if we're not supplying it, it doesn't get changed. This could be good news, but it could be rather dangerous. The reason why it's rather dangerous is that something like observed at is vital, and maintaining observed at is vital in order to use the temporal endpoints, which will come up in the next hour. And therefore, it is necessary to make sure that you've got a good stream of observed at values. If you fail to put observed at in, it won't change. You won't have consistent values. So this is a powerful endpoint, but you need to make sure you use it properly. This is the normalized version. As you can see, you've got property all over the place, but the concise version is also applicable. So all three of these payloads on that endpoint are you doing the same thing. So whether you've got value or you've got type property and value, or whether you've just got the key value pair, doesn't really matter. These are all equivalents. The concise or super concise is internally. The concise or super concise is expanded to the normalized before it is the operation is passed to the context broker. If you add in options key values on a GET request, you will just get back the first level of attributes. This patch endpoint also can accept the same options parameter. But in this case, what it means is that if I supply a name and it's already a property in there, I'm just going to update that property. If I supply a relationship like spouse and I just put a value in there, an object URN in there, it's just going to be the object updated. Other attributes are not going to be changed. Sub-attributes are not going to be changed. It's an intelligent merge. Now, this means that you could, in theory, do a get using option key values, modify the values you want to change, and do a patch to update the same entity. Now, if you had any sense, you'd need to make sure that you updated the observed at as well. We'll come to that in a second, but that would be a legitimate use of a merge patch. You couldn't do this using the existing /attrs endpoint or /attrs attribute endpoint. So you can see that these operations are all updates of a kind, but they are different updates and have obviously got different use cases. Regarding language maps, as I said, have got this dual nature. So if, for example, you wish to update the English language name of the city from Constantinople to Istanbul, then if you've already got EN Constantinople, you could say, I am putting in my key values. Now, if you've received that attribute using options key values and also already put in language EN, it will appear to be a property rather than appear to be a language map. That's the dual nature of these language maps. So similarly, when you're updating and you've got this decoration, these parameters decorations on the URL, it will do the reverse. It says, okay, if I put name equals Istanbul and I've put lang equals EN and I've put options key values, then what that means is I wish to update just the English language version of that particular attribute. This means that there is some limited key values support in the API as a whole. For the observed at, it is possible if you put that as a parameter that where an observed at has already been created. So in other words, if I previously at some point, such as on create, I have already created an observed at property of a property, it will be updated. So in this particular case, it is possible to update the temperature property and just say, okay, temperature is now 100 and it was observed at this time, which will do the additional work. There is still some discussion on JSON literal nulls. It is possible that this will be replaced by another placeholder. So whenever I'm talking about JSON literal nulls, you should say, well, there is some indication of null. This is what was proposed in the 154 specification for comments. There are certain issues with it, so it's probably going to be updated to use a specific URN for null. But effectively, you need to be able to put in a null value somehow for some update operations. You see, the problem is that JSON-LD itself does not support direct use of null. The JSON-LD specification says when it encounters a null on the input, it is basically removed from the document before it can get placed anywhere. So the example on the bottom of the screen where I've set precision is null does not make sense. It's basically the same as that slide without the precision sub attribute. Now, There are ways you can represent a null. And one of the things you can do is use this JSON literal null. As I said, it's likely to be changing, because the problem with the JSON literal null is that that in itself can't accept additional attributes. But this is the way that the Orion LD context broker currently supports on a pre-release build. As I said, once the specification has been clarified, it will be following whatever the specification is. The other alternative is to have a fixed URN for this, but these slides are using the JSON literal nulls. Now, NGSI-LD states that the use of null indicates deletion. So if you wanted to delete the precision property of a property from this value, you need to somehow say precision is null. So it's only usable on these 3 patch endpoints, because the idea behind context brokers is to be able to tell you what it knows about. A null is basically saying, yeah, we don't know. So typically you wouldn't have an attribute which is null in that case. At the moment, if you try and set anything directly as null, as I said, it's just ignored. If you try and put one of these JSON literal nulls as a value or an object or a language map, it probably goes for a bad request as well. Now, that was the section on patch. I'll just show you some live examples to try and embed the knowledge on that particular area. Right, so I'm starting up a little pre-release version of Orion LD at the moment, waiting for it to start up. This is a post request up on screen, as you should probably recognize. You can see that I've got category value, temperature value, and unit code. You can see that type is only part of the entity itself. That is still mandatory because I'm creating an entity, but I'm just creating the various elements within the entity. Send gives me the usual created, because everything is expanded as you would expect. I can then add in additional attributes or values. So this is just adding in a value of 8, which has got a unit code of C62. If I didn't need to put in the unit code, I could just go battery level 0.8. Unit code C62 is the UNCFAC code for unity. So it's basically going from 0 to 1 is what this is saying. And obviously the other element will come through as a relationship. For the batch endpoints, same thing occurs. You can, if you haven't got any metadata, you can just put the value directly in there. If you have got metadata, you need to have a value for the value itself. So let's create some more temperature sensors. You see I'm creating things at various different levels. You can, of course, mix concise and normalized format. So this one is in normalized format here. It doesn't matter. So basically your property is now optional. It said created, and it said I've created those entities. When I read, I can read using option normalized, and I can get all my metadata back. Every single one of those has now got a property, or in the case of the controlled asset, a relationship. If I just change that to concise, all of my properties have been type equals properties have been removed from the session, so you can see that it's working perfectly well. It simplifies things a hell of a lot. Now, if I go for options key values, what happens is you get just the first level information. You notice all the metadata has disappeared. The difference between concise and key values is that concise is still lossless. You've still got all of the information you need. You can you infer the types from the session. Now, if you go for options key values, that is no longer the case. Obviously, this is a useful read for a system which is reading from a context broker, which but it's not a useful format for data sharing, because it's losing information. But if this is what you're expecting, that's fine. It's not a problem. You can, of course, use things like the ATARAS parameter. You can see here options concise ATARAS category temperature controlled asset, just to get the relevant parts of the entity, and it will come in the correct format. Again, for the just on the straight ATARAS of type, it will give you everything either in concise, normalized, or key values. Once again, this has all got no property types in there. Now, what else have we got there? Here. It is possible, if you are that right, headers, params headers, this one. Yeah, if you change your accept header on the request to geo plus JSON, it will a context broker will return your format as GeoJSON rather than as standard normalized NGSI. You can see here that what we have here is a feature collection, and a feature collection consists of and I haven't actually put in any geometries yet. You can see that at the moment it's returning geometry of null because I haven't actually moved anything anywhere. This is an alternative output which is usable by GIS systems. Actually, what I will do is I'll just move my cows for a little bit. So is this X? Is this X? Localhost 3000. There we go. So I've got my little farm up and running, and what I'm going to do is I'm going to start my tractor and get my cows to move around a bit. There we go. Wait a second. You can see that one of my pigs is foraging, and other pigs were drinking, and so on and so forth. So it's probably long enough to actually get some data coming through by now. Okay, so if I now do this again, cow 10 is the first thing here. You can see I've got a heart rate here, and it's because I haven't put provided by in my at context. It's giving me the full long provided by attribute. Oh no, it's expanded for some reason. I'm not quite sure why it's done that. But you can see here that it's got a location, and the location is a piece of GeoJSON. And what that means is that when I look at the feature can have a geometry, and an observed GeoJSON feature collection can be pasted directly onto into a GIS system. It can be loaded as a CCAM collection, for example, to show what's happening right now. This is as opposed to, if I was just to change the headers back to LD plus JSON, LS LD. It would just be an array of, in this case, animals. And if I and you can see is it the bottom? Go to the bottom. You should be able to see that there's an at context in each element. Now, if I just go for application plus JSON, the difference is that I have now no longer got the at context in each of my animals. But you can see that because his option's concise, we've no longer got types in there. If I just change that back to normalized, oops, okay. Let's go back to reading it again. Where is it? The geo. Here we go. Normalized. And that you can see if I put normalized, I start getting not only type animal, but also heart rate type property. And once again, this works with, say, a list of IDs or whatever. So if we are, I'll just show that over here, code. So if we were to just have a series of IDs, comma separated, I want to find out temperature sensor 1, 2, 3, and 4, or 1 and 2 in this case. You can see it should be possible to start understanding what I'm doing here. I'm passing in my at context. I'm requiring whatever these entities, listing a specific set of IDs, and I want it in concise format. So unsurprisingly, when I send this, I will just get my 2 temperature sensors on that format. Well, that wraps up section 1. So I'm going to have a very short break. I propose we come back in 5 minutes, so about approximately 1/4 past. Okay, so I'll see you soon. get going again in approximately a minute and a half. Give everyone else a bit of time to get their cup of tea. This second section is rather long, so again, what I'll do is I'll split this into two. So we'll have another short break in approximately another hour, so that we can cover everything that's necessary. Right, welcome back. 4:15 here in Berlin. We've got a question on the chat. Are links for today's presentation available? The full presentation will be posted online in due course. For the slide decks, I'm not quite sure where they're going to end up, but they can be also placed into a public area. What I would suggest you do is, if you look at the FIWARE LinkedIn feed, where we are saying, we're doing a load of training this week, there will be a comment added on there as to where everything will end up, to make sure it's the right place. So answer to that one is probably not necessarily available right now, but soon will be. Before I move on to advanced operations, if there are any other further queries on the concise format. Concise format's fairly obvious, really, but it's not been formally part of the API until now, so it's worthwhile doing, because it makes sense, makes life easier. Regarding the various forms of patch, partial patch and merge patch. Merge patch is defined as a IETF RFC, so it's a well-defined process, and the original way of doing things is a kind of variant on that anyway, because both of them can accept nulls as well. So if there are any further questions, please start putting them in the chat. Otherwise, I'll move on to advanced operations. This is showing various bits of documentation which are rather useful. The latest NGSI-LD spec is currently 1.5 rather than 1.4, although there's a 1.5. There's 1.5.2, which is available comments for release, but they're all available on the Etsy website. If you want to get the code behind most of the stuff I'm doing today, you'll find it's embedded within the NGSI-LD tutorials, the URL there. It is perfectly possible to get hold of the Swagger specification for NGSI-LD endpoints, which is obviously quite useful if you wish to generate something as a context broker. Indeed, one of the projects I know about, what they want to do is effectively define the shell of a context broker to hide their own data behind it, in which case it would be, in order to make sure that you have a compliant endpoint, you can use this to generate your stubs, explain what's going on. Now, there are two parts to a Swagger specification. There are the endpoints, and then there's the models, the data which actually goes through the system. Because of the generic nature of NGSI-LD, it's not for me to tell you which models you're doing. You could be modeling cities, you could be modeling robots, you could be modeling car transformation or whatever. There are lots and lots of standard data models under the Smart Data Models GitHub, which was described by my colleague Alberto yesterday. And if you are creating your own, because of course your use case could be somewhat different to stuff which is existing. It'll be worthwhile reading the guidelines as to how to do it. Ideally, if you have a domain which you will be looking at potentially using for data sharing, or somebody else might be interested in using your models, you should provide these publicly. If you are using NGSI-LD, JSON-LD, you will require an app context file, and it's obviously very important that what you're referring to is available so that they can use it. There's also additional white papers on how to actually model these the real world using NGSI-LD, and that the white paper gives details about how you might want to say model a connection, or how you might when you would prefer to use an attribute, when you prefer to use a dataset ID, and so on and so forth. Well, let's move on to some advanced stuff. At the moment, I haven't looked at headers in more detail, but you will find that the existing NGSI v2 specification has got several well-defined FIWARE headers. Well, these are now NGSI-LD headers because it's not purely FIWARE who are involved in this anymore. So for NGSI-LD, there is the ability to split your data by tenant. So you can have one context broker who is servicing data for multiple end users. If you're looking at my agricultural system, for example, you could place all the data from each individual farm effectively into a separate backing database. And that would mean that I wouldn't be able to retrieve somebody else's data unless I was using the appropriate header, or perhaps more realistically, I would have some sort of security which would include checking the NGSI-LD tenant header as part of the requirements as to whether I can gain access or not. Now, scope at the time was not well defined. It has been added into the specification since this slide deck was first created. It is the equivalent to the FIWARE service path. Now, this is useful if you need to logically separate your data. If you wish to hold all your entities, let's say we're talking about IoT devices, you just hold these IoT devices. If you start adding in a scope header with these devices, you can say, well, these devices are held, I don't know, in this particular park, or even better, it's slash separated. So you could have a scope saying slash city name slash park name. Okay, so you can use that to just get the devices from a certain park. But because scope can be hold multiple slashed roots, and you can still use the comma as a separator, you could, in your scope header, you could say, I want to get the entities from this city and that park, plus this park and that location, and only those. So it's a way to logically divide the system. It is, I believe, currently implemented in the Scorpio broker. I'm not sure about Stelio. I believe Orion-LD does not currently cover this, but it would be useful if, for example, if you are, say, hiding your data behind a facade of a context broker, and you only wish to update one particular database in the background, you would use the NGSI-LD scope header to say, okay, I'm doing a patch, but I'm only doing a patch under this domain. And it's very much like the subscribe mechanism you use for MQTT topics, in that you can put ++ slash and elements like that as wildcards. So you can actually fine grain tune what's actually coming in. Now, the reason why the NGSI-LD tenant was required is that there are use cases where you don't want to keep all your context broker data in one place. Obvious case in this case is that I'm buying your system. You have got my data. You hold my data because I'm paying for access, and I don't want my data to be mixed up with the data of another client. Since this is obviously a legal requirement, it is necessary to be able to cover that. Moving on, we're going to go through some more headers. The supported content types, or the main supported content types, are application JSON and application LD plus JSON. And on the right-hand side, you can see the example John Lennon entity in the two formats. The only difference is that the at context is in the payload body if it's application LD plus JSON. If you don't put LD plus JSON, just put application JSON, then the response looks as if it's just a bit of JSON. The at context, however, has not disappeared. It's just moved from the body of the response to the header of the response. Now, the link header is again a well-defined HTTP header which adds additional information. You can see it's got this angle bracket and then some sort of URL in it, and then it's got the information about rel, which is what is this, and type, which is what does this particular file hold. So this link header is stating there is an at context file, which is defined by W3C, which in itself contains application LD plus JSON data on that URL. In general, what I do is whenever I make a request, I always include the same link header. Whenever I get a response, I always get the link back from the in the header format. You don't need to clutter up your payload bodies if you know that you're talking directly to a context broker. Context brokers will always have this link header ability, this link header thingy. Context brokers will also always append the core context, which is the lower one of the two values in the green on the right, automatically. So it is a mechanism for reducing the size of the payload. This is different if you want to do a subscription, or this is different if you want to push the data to somewhere which isn't context broker related. It may be the case that you want fully valid LD plus JSON as your response so that it can be used by the next microservice on the chain. In that particular case, it is probably better to have application LD plus JSON. It is probably better to push the data into a single file. I can then upload it and push it elsewhere. One way to look at this is that if I put the file onto a USB stick and stuck it into another computer, has it got enough information or not? And the answer is, if it's the link header, no, it hasn't, because it's all together. However, the lower of those two examples is a totally valid JSON LD document, which happens to be in NGSI-LD format, but it's a JSON LD document. So that should be considered as to how separate you need to do this. For my at context, I would generally use one level of indirection. So the context file I would use as path to my public server NGSI-LD context JSON typically would hold wherever wherever my models are plus the core context, and then it would make another request to, in this case, FIWARE, GitHub IO, data models, context to get the rest of it. Now, because we're talking context brokers, and because context brokers always implicitly run the core context last, in theory, you don't need it. In practice, it's safer to be include it in this additional file. As to what the best practices are for this, there's more information directly from the JSON-LD folks. For the accept header, as I said, there are now 3 payloads which are retrievable: JSON, LD plus JSON, Geo plus JSON. However, custom formats may be supported as well. It is, if you're, for example, you're using Orion LD, which is one of its quirks is that it has a backwards compatibility mode to NGSI v2. It is possible to request additional formats for your subscriptions, not for your standard CRUD operations, or the CRUD, read the CRUD. But when I'm raising an event to another subscription, I may wish to get my data back in NGSI v2 format, in which case they've got these options X minus, which is obviously X minus meaning it's a custom format, and then whatever, whether it's key values compacted or whatever. The difference between key values and key values compacted is that key values will include the long IRIs for each attribute, whereas key values compacted will just use the give you back the short names, which is fine if all that the component that you're using for backwards compatibility reasons has just got the ability to deal with the short names. Using custom formats is purely for connection to microservices. Do not use them for data exchange. Reason being that for data exchange, we want to have the one standard format, NGSI-LD, for going between various different locations. So buyer beware on that example. For a GeoJSON request, you can obviously add in a wide variety of parameters. So again, using an agricultural version, you can say, give me all the animal entities. In other words, that's the type equals animal, which are, in this case, pigs and calves. So it's got a species, which has got pig, and it's got but the Q parameter is not only just pig, it's pig, semicolon, reproductive condition in calf. You can see that's both pig and calf are in URI encoded format. This is the way that you would normally request data from a context broker. If you've got a microservice, it almost certainly do it automatically. But this is just being totally open about what the changes are. So pigs and calf found within 2 kilometers. Okay, so there's going to be 2 kilometers of a point 1336 52 east, which is in the middle of Berlin. So in that particular case, if you're doing a GeoJSON, geo fencing request, you need to use the GeoRel and geometry attributes. GeoRel in this case is going to be near a maximum distance of 2000 because the distance is by default the unit is meter, and obviously it's within a point, but you could actually do additional actions or if it was a polygon or a line string or whatever. And then that you notice that when I'm describing this so far, I'm saying, what do I want? And what do I want is usually the parameters on the URL. On top of this, I want to return this as key value pairs. That's the options parameter. But then you can move on to other returns of the format, which are all headers. This is the -H stuff. So I'm only looking for data from one particular tenant, OpenIoT. I want to have this data back as geo plus JSON. And then there's this prefer header, which if you're doing GeoJSON, because the application for geo plus JSON is a standard MIME type, you do not have the option to have application geo plus LD plus JSON, which is just a made-up MIME type. So in this case, the additional preferred header says I want to have the body as JSON or the body as LD plus JSON. This is what the response would look like. So in this particular case, I've got a pig called Tango, and she's in calf. You can see that because I've requested options key values, there's the last D point there, I'm not getting all the additional metadata. And you can see what I've done here is I have put this onto the map. This was the example which I showed on the demo just before the break, which means that you can have any query on the /entities will return as a feature collection. If you are just returning a single entity, it will be a single GeoJSON feature, and the feature itself is effectively the stuff which is inside the feature collection. Feature collection is basically just a fancy way of saying this is an array, but it's the way that GeoJSON works. Of course, that means you can post it onto a GIS system, as indeed I've done here. You can see that in this particular case, the geometry, the point, is being displayed on the screen, which means that my pig is wandering around Tiergarten Park. You can see if I click on the button on the marker there, I can get more information about that particular point, and that includes things like the name of the animal, legal ID of the animal, the sex of the animal, and also the location again. All of the properties which are defined within the entity, including the location, are repeated in the properties attribute of a feature. Temporal interface. You can make requests which cover things like give me the last 5 readings about a single entity and return in default normalized format. This is an optional interface on context brokers. I believe that Stelio and Scorpio offer this by default. Orion-LD does not, so you have to use an additional add-on to get this on Orion-LD. One thing to note about the temporal endpoint, which is under /temporal/entities rather than just /entities, is that it may or may not, but it is possibly under a different port. So this is all optional. Effectively, what the temporal interface does is it basically switches the context broker from giving you the data about the now to actually having a memory, so you can find out what was happening recently. Now, this is an example, and it does come at a performance hit, because obviously you'll need to store all this in the data somewhere. You'll need to be able to access the data somewhere, and it's getting the information back out. It's more difficult to see what's going on. So it says here that there is an example short sample Docker compose. Let's see that in action. first thing it's doing is it's starting up the elements which are part of the additional add-on, and then it's giving the main system. It's now adding in some data. It's going to wait for my context broker to be available, and it should start up in a second. All this, these stages of adding in an IoT agent and getting hold of the data and things like that will be covered in the next session. So again, I'm just worrying about the context broker information. Once again, I can bring up a dummy device, go onto the farm, and start my tractor. Now, at this point, we're starting to send information about various elements of the farm into our system. You can see the heart rate of the pig and the cow is slowly changing. So, code. You can see here that I have a request to get a set URL. I'm looking at cow 1, and I want to get the last 5 values. When I make a request, and it's not working on me for whatever reason, viewing console. I'm not running. Okay, we just had an error. Just a minute. Let's see what's happening here. Try sending that again. No, it's not working on me. Okay, live demo is not working. Fine. Right. So when I I'll get that going in a second. Just check if there's anything obvious what it's doing. Oh, it's not started. Okay, I see what's going wrong here. It's failed to start up external. I'll just show you the I'll just show the response on the slide instead. So when I do a successful request and for whatever reason it's not entirely working, what I can do is I can get showing it. Yep, present to view. So if I was to get the last 5 whatever, I would get back for each each entity. In this case, the ID is cow 1. I would get back all of the information I know about that particular cow on a regular basis. Now, what's happened is that whenever there is an update, a change, all of the entire entity is copied to a separate database, and it's returning every single attribute in normalized format, plus including a so-called instance ID. This instance ID, which you can see on the example on screen, is typically the same for each attribute in the single record, is usable for keying should you need to update it or amend it, basically give people the right to forget. You need to have the values as shown. Now, if you look at the location or the heart rate, which would then give you more values, obviously the values themselves, the properties of the properties may be changing. So it is possible that you can have a location geoproperty, and it's got observed at, which is a non-rarefied property of a property, but it's saying for geoproperty, this was the instance ID. For however, I am also got this provided by relationship of a property, and that in itself would have an additional attribute. What would happen here is that it would be possible to change an individual property of a property. One thing about temporal data is that temporal data gets very long very quickly. So what I tend to do is I try and keep the slides a lot shorter than necessary than the full responses. In this particular case, the way that you key on a say a moving cow or whatever is that the attribute must have an observed at. So obviously that is showing these things have changed over time. Now it is necessary possible to make temporal queries on something which isn't observed at, and this is slightly more complex. In order to make a temporal query on attributes without the observed at, so for example, give me the last 5 readings about all female animals, would be you are doing the Cue parameter, which again we should recognize from yesterday. It's just one of the standard things you do on entities. You also can do it on temporal entities, but in this particular case, the attribute sex doesn't change. You know, it's defined at birth. It doesn't change. So there's nothing which is observing it. So if you want to do an observed at on an attribute which doesn't change, you should look at its time property. Now, the time property is, as I said, usually going to be observed at by default. However, there is also another system-based time property called modified at. There's actually another one called created at, not that's terribly useful. Now, I mentioned modified at when I was talking about the overwrite put endpoints, saying that the put was not fully idempotent. This means that when the reason for this and the reason why this works is that whenever a record is updated, modified at is updated, regardless of whether it's got an observed at or not. And therefore, it is possible to do a query across the a non-observed attribute by using a modified at. The rest of that query should be moderately familiar to you. Type obviously is going to be filtering by type, options count. Oh, I think I'll cover that in the next slide. Options count is going to make sure that it tells me how many entities are available. The obviously last end will just retrieve the last 5 values. It's got a page size of 2. So it's going to, what that's saying is that I want to get the last 5 values of just 2 cows. If you add in this time property value, then instead of just getting the observed at in the payload, you'll get both the observed at and the modified at. It should be noted that it's still worthwhile putting in the observed at. You can see from this particular example that the observed at was at 25 minutes to, whereas the modified at was 2 minutes later. This is because typically when you're talking about slower systems, such as agricultural systems, where your device might only wake up once every 30 minutes, the observation could have occurred pushed to, say, an MQTT server half an hour ago, and it eventually wakes up and it eventually reaches a context broker. So if you want to find out when things actually happened, that's when you need to have an observed at property. If, however, you just want to see when things were changed in the context broker, then that's what modified at is. Modified at is the last confirmed value and not necessarily the last change of the value. This is because if you push the value 7 into an attribute, and then half an hour later you push the same value of 7 into the attribute, it hasn't modified the state of the entity, but it has got a stronger indication that the value is still 7. Therefore, modified at doesn't literally mean modified within the entity. It means modified as far as our confidence in this value is concerned. So if it was half an hour ago and now it's 3 seconds ago, it means that we're more confident that the current value in the context broker is whatever. So this is not necessarily a change of value. It's not last changed at, it's last modified, and it's modified confidence. So I mentioned options count. If you look at a working options count, and I've got a recorded demo which I'll show in a section sec. What will happen is that you will get a couple of headers in addition to your response. So if I'm saying, give me the last 5 responses with 2 cows, page size of 2, and there are 30 cows, in this case, there's 174 animals which are covered by this. We're just doing sex female, so it's both our cows and our pigs. It will give us additional information as to what's coming through. So I will make, if I do a request, I'll get the following headers back. We'll say, okay, the date time range is fairly obvious. This is the time range which was covered by your query. So the last 5 values were between this time and that time. The results count is saying, at the time you requested it, your request, you could have got back 174 entries. And then the page size is saying, well, what I actually returned was just 2 entities. And then you've got this next page, which would say, it would also be a previous page potentially, saying whatever the ID of the next entity you wish to return. So in this particular case, what would happen is that I would get, say, cows 2 and 3 as being females. I think cow 1's a bull. Cattle. The first one's a bull, so it's the next 2 are cows. And then it would then return saying the next ID which is relevant is cow 004, and you can add that in as a page anchor. So you can use this to filter and then paginate and then get the various limits as necessary. Temporal information can also deal with time limiting. So you can find out things after a certain time, or before a certain time, or between a start and end time. So once again, if you can make up a sentence in English, you will, in general, be defining the parameters which will be on part of the URL. So if you're saying, give me the heart rate, the location controlled asset, actually it hasn't got heart rate in the one below, give me the location and controlled asset attributes of all device entities within 180 meters of location in Berlin, and return all readings taken since 8:30, and given them 2 devices at the time. You can see that the working our way down the various URL parameters, -d in curl type device, okay, and these are the attributes I want to get, just location and controlled asset. And then options temporal values is like the cousin of key values. in the ordinary entities, and we'll show you the payload in a second. And the obviously the other parameters like the GRL geometry coordinates you wouldn't know beforehand. Time rel is just saying from after. This is after the or can be added in as part of the like the last n, because obviously last n will only give you the XYZ, and by default time rel is now, and before now is the default. So this is saying time after and a specific time. The headers, as you should now start to understand, are my standard link header, which is defining my world, my accept header, which is saying I don't want JSON-LD in the body. I want it returned as a header, and in this case, my tenant. Temporal values will return a tuplet for each change of a value. So you can see here for the heart rate, what I'm getting are it's saying it's type property, and it has values of 61 at that time, 58 at that time, 43 at that time. So you can see each it's an array of tuplets for each value. Similarly, if you have a numerical value like an object, it will be that object for each particular element. So the geo property, as you can see, it's got a GeoJSON objective type point, which is saying this device was reading pig collar 01 was reading at that particular location as time went by. Similarly, for relationships, it's just going to be the same thing, except instead of having a values attribute, it will have an objects attribute, where each tuplet will consist of an IRI, such as animal pig 01, and the value which was placed in there. So properties, and that includes geo properties, it will include language properties, are held in values arrays, whereas although actually I'm not quite sure, maybe language map needs to be language maps, I'm not sure, but typically the properties will be held in values arrays, relationships will use objects. Right, how are we doing for time? Okay, fine. I'll deal with language maps as well whilst I'm at it. The idea behind the language map is that you can whatever you can do in JSON-LD, you should be able to do in NGSI-LD. And if you were to have a car which is on the street known as Grand Place in Brussels, it's also known as Grote Markt in Brussels in Flemish Dutch. So you can see there's no hierarchy here as to what the name of a place. Both exonyms are perfectly valid. Another example I came across recently is if you've got a database of names in somewhere like Tunisia, you'll find out that your name will be your name in French or your name in Arabic. They're both equally valid as far as returning the information about that person is. Now, this is quite useful because we were able to then make queries based on whichever natural language we would prefer. So the difference here is that as far as JSON-LD is concerned, if you have a relationship object, under the hood, this is defined as a JSON-LD at ID, and at ID being a pointer to an IRI, which represents a unique object, hence the name. Whereas if you are defining what type of an entity is, it is, funnily enough, a JSON-LD at type. The at type used to set the type of the node or the data type of the node. So you can tell that this vehicle is so this URN is a vehicle. Now, Similarly, value is also well defined. Value is basically an at value, and an at value is basically just purely whatever you want to throw in it. It's the value of the whatever. So in this case, your brand name has a value which is a string, which is called Mercedes. But it could equally be a JSON object. It could be a Boolean. It could be a primitive. It could be a complex JSON object. Doesn't really matter. Language is a specialization of this system, and you can also see that it's basically just an object, but it's a well-structured object, and each either key value pair. Each language uses it's BCP 47 date. I can't remember what the thing is, but FR is French, NL is Dutch, and has got the relevant data on the right hand side, either a string or potentially strings. Now, it is possible to retrieve a language language data in as a single property. So if I have all the name of a street in both Dutch and French, and I'm just interested in French, then it is possible to make a GET request and add in the lang parameter to say, please give me as much as possible what you know in FR French, and it will just suddenly transform from a language map into an ordinary property. So, but it will have this additional sub attribute lang. So we'll say, oh, by the way, what I've given you here is the property, the value of this street, and by the way, it's in French. Now, the rules for defining lang are the same as you'd come in on the accept language header in HTTP. So obviously, if your browser usually sends an accept language header of some sort, and it's usually you have a preferred language. So you could have a language EN only, or you could have a language which includes variants. So, for example, FRCH is going to be Swiss French as opposed to French, or FRFR would be French, or FRCA would be Canadian French. You can have those at either the same level, or you could have a decreasing hierarchy. So the decreasing hierarchy, which also includes wildcard ranking, in this particular case is saying, I prefer Swiss French or French if you've got it, but frankly, I don't care which one you give me. The fallback on that will be English, and the fallback thereafter will be any other supported language. Now, according to the official definition of the accept language header, websites shouldn't give you a language unless you put the wildcard in there, which actually, frankly, is rather stupid. Because if my preferred language is English and I go onto a Brazilian website, I would prefer that the Brazilian website gave me something, even if it's in Portuguese, rather than doesn't give me anything, or saying, sorry, I can't supply your supported language. So context brokers do the same thing, rather than defaulting to not being able to return anything. It will return to a language, which is probably broker specific, or rather it will be a hierarchy of fallback languages. So you should be able to set up the language to say, yes, give me English if I can't get anything else. Within the language map, you can set an at none in JSON-LD, although I don't think this is currently part of the NGSI-LD specification. It may well be added in at some point. Languages are limited to simple strings. Indeed, it's actually strings or arrays of strings. But in many cases, you may wish to define something a lot more complex as being this is French. So here I've got the classic event, which is Bonjour le monde, which is obviously a French version of Hello World. And you can tell it's French because the description is in French, and it's got an in-language property. This is defined by schema.org, which says, by the way, my object, my entity, my overall thing is a French thing. In language is the preferred way of keeping the semantic meaning of an object without adding in too much bloat, because you wouldn't want to have the entire object as being inside a language map. Language maps are just strings, so you need to have an indicator that this is in French. Similarly, if you had a series of events, one in French, one in English, one in German, you can use some sort of relationship, such as the same as relationship, to link Bonjour le monde to Hello World, or Bonjour le monde to Hallo Welt, depending on which other languages are available. In language, of course, if you define it as part of your world, you'd need to make sure this is part of your at context, can also be part of a property of a relationship. So if you get back the whole of Bonjour le monde, it will actually give you sufficient information to say, oh, by the way, we also have equivalent entities in English, in German. The reason why it is done this way around is that, to be honest, not all the data model users will need internationalization. It tends to be things like, say, governmental or mobility or smart tourism, which is would find this very useful. But if you're in, say, something like robotics, or you're in agriculture, or an awful lot of smart cities, to be honest, it's not really necessary for your models. Now, I keep going on about this at context file, and the fact that you can have one, and it's saying that all the short names I'm using are these, and all the long names I'm using are these. However, your client, whoever wants to read your data, if you're going into a data space, doesn't necessarily need to be using the same values as you are. And in this particular case, what you would do is you would use what's known as an expansion compaction operation. This is fully supported by a load of JSON-LD libraries. And what that does is that you take your payload, you expand everything you can in that payload based on the at context file. You then have a second at context file, which would then be able to have different values, and you can then compact it back to your preferred short names. So expansion compaction can operate on any JSON-LD document. And indeed, even key values is a JSON-LD document. You're not just talking about the context. So here, I'm just using a standard Node.js library here, which just goes through, get hold of it, expand it, compact it, and send the compaction. What this means is that you can, say, have a NGSI-LD representation where all the attributes are defined on my basic model, with like address and location and name and category. And after having gone through an expansion compaction operation, what I have thereafterwards is the same data, but all my terms, all my information is now available in Japanese. Now, if you look at the second row is saying type in Japanese equals building in Japanese, because building itself is not one of these terms which gets expanded and compacted. Type itself, you can see type multiple times on the on both slides, is changed as well. The important point to note here is that although the right-hand side is valid JSON LD, is no longer an NGSI-LD representation. The NGSI-LD representation deliberately, and this is where the definition specification comes in, deliberately places the core context at the end of the chain of at context files. So you wouldn't be able to override ID and type using this, because these are key terms. Similarly, property is a key key API term that wouldn't be overridden either. Things like address, attribute names can be overridden, but it should be borne in mind there are some attribute names which are in the core context, like location, because it's so special, or observed at, and those would never be changed. Another point to notice here is if you look on the right-hand side, the sub-attributes of the object of the address locality, the postal code, street address, and what have you, have not been transformed, because that is just an object. And what we've actually stated here is that the address is a schema.org address. A schema.org address has the following attributes: street address, address region, address locality, postal code, etc., etc., etc. So there's the agreement that both of these systems have sub-attributes called address locality, address region, postal code. You'll notice that the order is slightly changed. Order is not going to be not necessarily going to be consistent. However, of course, it doesn't matter when you're talking about in-memory representation. You know, all the attributes are still there. Going on about data exchange, context data is data for data exchange. Therefore, there are limits on what data you should put into a context broker. All dates within a context broker, such as the observed at date, are ISO 8601 dates. That means it's got year, followed by month, followed by day, hour, going down to I think it's milliseconds. And it's typically using Zulu time for the location. This means that anyone can read that date. If I wanted to make my data really accessible to a third-party system, which is what I'd want to do if I'm using NGSI-LD, I shouldn't go around putting my dates in French. What I should be doing is I should be leaving the date in the context broker in ISO 8601 format. And then it's for the front end to do the necessary changes to say, hey, this is vendredi or whatever. You can see there's there are plenty of libraries out there like Moment or the internationalization format or whatever. I think that's Java, is it? Something like that. It's either Java or JavaScript, I can't remember, which would then be able to style your date in the format of your choice. That is not something which a context broker itself would need to do. Similarly, if you want to go in and deal with collations, you do not want to put that data directly in as your attribute. So let's say you're dealing with streets in Spanish. What you could do is you could have the name of the street in proper Spanish so that you can display it properly. But what I would do is when I'm updating or inserting or updating it, I would have a property of that attribute, that name, called collation. And I would then do whatever is necessary so that I can access it properly. So in this case, I'm going to say, okay, what I want to do for my collation is to remove all the accents. That's just replacing a load of Unicode characters. And I'm going to make it all lowercase. So I don't care whether it's uppercase or lowercase. What we would then have is we would have a property of the property, collation, which could be very useful to query on. You can query on, remember, you can query on properties of properties using the dot syntax. So you could go name dot collation. This is opposed to the querying on the sub attribute, which would be using the square brackets. So it'd be address square bracket city name close bracket. So you can use the queue, still use the queue parameter to make your requests and then retrieve your data. This way it's much easier to mimic the values of a database. Now, if you're not sharing your data across multiple context brokers across data spaces, then maybe the way to go is to actually copy some of your context data into a database and actually use a database and the collation index of the database itself. So, if you want to order your values in Swedish, fine, you have to use the Swedish collation order. However, if you're looking to exchange data, and when you're exchanging data, you haven't got the luxury of being able to do clever things from databases. You have to do it yourself, and therefore this is the reason for having a collation attribute. So you can see the final example, the German one, where you want to get rid of umlauts. You want to get rid of S-set. Basically, you want to make it into a nice simple collation, which would allow us to look for something. You could get a street name like Schöne Grüße, and it would actually come across with OE and UE and double S, so that we could actually do that as part of the query. More context broker anti-patterns. This is moving on from stuff which either context brokers can do if you tell them about it, or context brokers do because that's what context brokers do, to what context brokers don't do at all. If you have the need for any of the following, it probably needs to be held outside of the context broker. So let's say, for example, you have you're trying to store images. You do not want to store binary data types or some sort of encoded I don't know, SVG or whatever in your context broker. There is no blob type. Typically, you would have properties which are numeric or simple strings. If you're going much beyond that, then you've got to have a good reason for working out why they are atomic. Obviously, in the case of an address, the address itself is atomic, so it's got some sub attributes in it. But typically, my temperature is currently 7. My temperature is now 8. My temperature is now 9. You can tell it's rising. So in this particular case, you would, if you really want to have, say, I don't know, an image of a number plate, you've got a number plate detector. It's showing what the latest latest vehicle to pass my gate actually is. So it's a sensor, effectively. If I wanted to store that image, I would probably have an attribute which is number plate detected. Fair enough. I would have another attribute which would be stored location. and I would push the stored location to say Amazon S3 or whatever, saying this is where my image of that thing lies. It's a link to data storage. You have if you think about it, then what you've got within the context broker is a manageable set of attributes and a manageable length on the value you're going to get. Sure, you need to make multiple requests if you wish to get hold of the image itself, but that's the way things are. That's because we are using a distributed system. For predictions, again, this is if I want to make some sort of ad hoc prediction, maybe that's a URL to some sort of third-party system, so I can get hold of what I think will happen next time. But what you could happen is if I have a system where, based on my context data, I think something will. I want it to do some business logic so that it'll work out what's. I think this is what I think will happen next. That is probably either an external service or a cron job. There's been webinar. If you look at the FIWARE website, there are a couple of webinars on how to do MLOps, and that is doing it the right way, where based on your prediction, you then potentially feed back additional data as attributes. Real work being done by other microservices. It is not something which the context broker itself deals with. It can't make predictions. What it can do is it can point you to other things which can make predictions, or it can be fed the values which our current model can deal with. So that is coming up to the second hour, so it's probably about time for me to take another cup of tea. I'll try and see if I can get my demo up and running. So what I would suggest we do is that we take another short break and come back at past. If you've got any questions, now would be an excellent time to get the thing up and running on the chat. Have I got that up there? It should be there. And in the meantime, I'm going to get myself a cup of tea and give my give my context broker a quick once over to see if I can get that demo up and running. I'll see you in a little bit. Right. Rather than fixing a live demo on the fly, which is probably due to the fact that I've changed from one machine to another, I'm going to be presenting a short video of that demonstration, which I wish to wish to show. Got the screen up and running. So let's see if this works. Let's have a look at this. Let's have a look at this in action. I'll try and get my little demo up and running. There are this a sample Docker Compose on the FIWARE GitHub, so you can actually start these up. In fact, there are multiple Docker Composes, because this one deals with Scorpio, it deals with Orion, blah blah blah. Now, the point here is that you should understand that from this diagram, the backing database, in this case, because I'm going to be using Orion LD, so it's quicker to start up, in this case, a timescale, is not necessarily the same between different context brokers. If you were to use Scorpios, you'd be using Postgres with Postgres. If you're using Orion, you'd be using Timescale DB. That might change in a future version. So is it the case that you can't see the video? Can you actually see my screen? I can see and hear videos. So I've got one problem from Gernot. So if majority of you, okay. So if you've got any problems, you should talk to Sasha. He's fixed it. So you just need to reload your web page if necessary. I'm going to continue playing the video. For all I know, it's not necessarily the case that the memory is a well-exposed interface. Now, you could directly make requests to timescale. I wouldn't recommend it. You're better off just looking at the data itself. You can see this is a relatively simple add-on architecture. All we've got this additional component, Mintaka, which is running in combination with the Orion Context Broker. This time I know the demo will work. Let's start up the containers and see whether we can get something to run. Now, I've split my Docker Compose into two parts because I want to make sure that the add-on is running before I'm starting. You can see this is just the Mintaka component. You can see at the bottom half of the screen, I'm loading a timescale database. I've got some various standard attributes. Obviously, in any secure system, I wouldn't put my username and password in clear text, but you've got the idea. It's just something sitting on the web, and it's something I can access. Whatever username I'm putting into my system, I need to make sure that the Mintaka component has got the same name. So the same password is Orion, database is Orion, and it's a timescale. Now, the number of threads which you want to use, pool size, you could end up with starvation. So it's a good idea to make sure that you're not using too many threads at one time. I'm putting in information like endpoint info enabled, so I can actually do a health check, say, are you up? Are you running? And I need, obviously, that may or may not be sensitive. Now, let's see if I can see if we're running yet. Oh, still provisioning devices. Okay, so we're going to wait for a short period whilst the thing's actually loading up. Obviously, it's creating the scenario I'm talking about. It's created 30 cows and pigs. It's linking devices. Obviously we have a device which is recording the heart rate, but also we want to have the heart rate on the cow. So we need to be able to push that information elsewhere. And now we're up and running. Right.
Okay, so let's start off by looking at the device monitor. Yeah, farm is currently asleep. Let's start our tractor. The tractor's now started to move. And you see, we've now got various pigs and cows. They're all at rest because they start off inside the barn. But at some point, you can see that the animals will start, like pig 2 is currently foraging. They'll start changing their status. You will find that the location is moving slowly. And obviously, I've got quite a large cow. You can see all the pigs are coming through at the moment. Now, this is difficult to see on with raw data coming through. So let's see what happens when I actually make some requests using my context broker. So those are the last 3 entities here. So let's see if animal 2 has got some data in the system. It will take a little bit of time to begin with, because obviously, like any NGSI-LD system, it doesn't know initially what the context is. So it's going to have to download the context data, which is, I think we've got it here. Where are we? I've got it here. Where's my context data? Yeah, you can see it's going to have to download my context. And this has got all this information. It's in a well-known location. It takes a bit of time to process that. It does that once, of course. It then would purely cache that, and then next time I'm asking for the same context, it doesn't have to do it again. Because of the nature of JSON-LD, you could, in theory, have all this embedded inside your requests, so it gets rather complex. But the best way to do it, and indeed, if I show you the other thing here, is to have, say, a web server, like in this case it's Alpine, which is just serving that file from a well-known public location, and it's within this system, it's known as context. So you can just get hold of it. Now, again, looking at the Orion part of this, because this is split with an add-on, you can see here, again, we have the environment variables, which are saying, okay, I want to persist my data into a timescale database, and these are my username and password, which obviously shouldn't be in plain text, but you know what I'm talking about. It is worthwhile mentioning that normally when I'm doing my demos, I would leave the log level at debug, but of course, this is getting a bit more memory intensive. I've only got a small machine I'm running. Things can slow down quite quickly, so I've changed the debug level to error. It's not really a problem, but you can, and indeed I've done it myself, run into difficulties if you're trying to do too much on one particular system. So you want to containerize properly. You want to make everything do one little job. You want to use things like HTTPD to do a separate thread for doing the context and what have you. So where are we? Let me go back to this. So, okay, so eventually after it's returned back my query as you'd expect. This is cow2, and cow2 has been done on various different places. So it's moving from one location to another, and you can see the heart rate is slowly rising. This is given the last 3 options, and I was going the temporal values. So you can see you've got the tuple key value entries. Now, it's possible I'll get to get more information. If I that's right. If I want to get animals, if I modify that, find out my. I can also add in things like I only want to get the sex and heart rate, and I only want to get values which are before a certain date. This is currently a date in the future. I send that, which should be a little bit quicker second time round. Obviously. Performance will depend on how you actually set up a proper system rather than what I'm doing here. At the moment, yeah, you can see that took about, and it's giving me partial content. The reason why it's giving me partial content is because there are, I'm asking for a page size of just 2. animals, and of course I've got more than 2 male animals in my system. So it's giving me more. It's saying yes, I've returned information, but there's more. If you want more, you're going to have to do something else. Now, this is, as I said, temporal informations get very, very long. And this is only 2 entries. It's already 62 lines along here. But it's giving me some headers. And the headers are saying things like, well, I have retrieved data within that range of dates. And I also can tell you, I know you've got 2 cows, but there's a pig 1 who's on the next page. And we can actually use him as a page anchor next time, which is saying I can start from the pig 1. And I'll go back to the body again. If I make another request and add in that page anchor to my request, I can say, okay, well, instead of getting cow 1 and cow 2, we start from pig 1. Send that. I'll find out more information about the male animals on the farm. And it should return back an additional information. So you can restrict what you're after by saying, yes, I want this animal, that animal. Now, you should realize that context brokers are potentially federated, they're potentially talking multiple systems. So there may be more animals on the farm than you would expect. Here's pig, after pig 1, we do pig 3, and pig 1, you see, is pig 1, come back again. So we've got those information there. And if we look at the headers, this time it's saying, okay, we've got the next one's pig 5, the previous one was cow 1. And you can see overall there are 17 male animals on the farm. So that is due to the count options. So that was a little demo of temporal interfaces. Pagination. This is more.
So that was the demo which I was supposed to be running beforehand. The reason why it was quite slow when it was running beforehand is because the machine I was using on it was massively underpowered. Problem about running on my new machine is it's quick to start up, but there's some sort of error in the way I've downloaded my Docker images. Now I'm not going to waste your time spending my time to debug it right now. So we can get on with the main part of the presentation. That's the wrong one. That's the wrong one too. So what I was doing just before the break is saying, a context broker is not a silver bullet. Don't go around trying to get a context broker to do stuff which you really shouldn't do elsewhere. When you are designing your system, if you're not getting the sort of results you would expect, then you're probably architecting it in the incorrect fashion. From the demo, another reason why it was taking ages to get hold of the app context was because there just wasn't enough processing power. The way you get around that, of course, is that you'd actually put it onto a proper cloud system. You'd have proper resources to be able to get hold of the information. I mean, it should have been a lot quicker than the actual demo was. But what I had, and indeed you can download this from the internet, is something which although architecturally unsound, is something you can run yourself locally on a single machine. Filtering queries. I said beyond simple CRUD. There are when you are doing a series of different requests, you should always try and minimize the payload you are retrieving. Now, therefore, you don't want to get hold of everything. You just want to get hold of as little as possible. One way you can do this is to say, okay, I just want entities of type X. Indeed, if you're looking at NGSI-LD, I think it's mandatory to have type in the when you're using Q. On top of that, you can filter your attributes. So in this particular case, I just want the stocks attribute and the number of items attribute. This again reduces the size of your payload, means it should be quicker to return. And the third parameter, which is again so you can reduce the values you're returning, this is not using Q but using ID directly. ID is obviously every entity you have must have a unique ID. Typically, the ID will be URN, NGSI, URN because it's a URN, NGSI-LD because that's the format we're using, and then the entity type like animal, and then the unique identifier at the end. Now, obviously, you can only be guaranteed that particular URN is referring to the same entity within your own federation. Because if you've got a completely different data space, they might be reusing values you've got. You'd hope they wouldn't, but maybe they are. So in that case, what you would need to do is to have a common defined attribute, like say legal ID for the animal, so that you can access the data directly. If possible, try and get a common ID, and that's much easier to use federation the way federation is supposed to be used. However, if you for whatever reason can't do that, maybe you'll need to have some sort of data ingestion from this third-party system. Maybe maybe that can change the IDs to being whatever I've got locally. So in the case, for example, let's say you've got your farm and you've got a vet, and for whatever reason the vets are using different URNs, then you would have to have some sort of data ingestion to transform it to your preferred terms, so that you can do queries across the multiple brokers in one go. For all of these three parameters we've got, they can take a comma separated list. It's either comma separated. It's comma separated for values. It's usually semicolon separated when we're talking about the Q parameter queries, because that can do ands and ors, and it can put brackets in the right place as well. The short names must be defined for both type and attrs, must be defined in your at context. You saw in the video I had a series of key value pairs for all the aspects of the farm, like this is a tractor, this is a temperature gauge, this is a temperature, this is a location, this is a heart rate, whatever. You can still use your short names, and indeed, nice short names are going to mean the query parameters will be nice and short. But obviously, you must link this with the appropriate context. I mentioned this final point a little bit earlier, is that key values is a great way of just getting the data. I don't care about the metadata. I don't care about NGSI-LD. Just give me the IDs and give it to me nice and quickly. You'd use normalized if you are translating between separate clients. Concise is probably a good halfway house when it's more under your control than under their control. Obviously, normalized is the gold standard for passing data between systems. So if you can get away with concise, use it. If you can get away with key values, use it. It's a lot shorter, but consider what actually needs to be done. usually with a chain of requests, because if, for example, you've seen the little supermarket app, which means you're able to buy beer. What happens is you have a building which has a relationship to multiple shelves, furniture items, and each furniture item has got multiple products on it. So you need to navigate the knowledge graph when you enter building 1 to find out where what items are on my shelf, where am I buying beer from, and then you can reduce the stock on the beer on the shelf as necessary. So bear that in mind, that sometimes you need to do a chain of requests, which is different to the way that databases work. Of course, databases, you do things like your left join or what have you to try and get one query to do everything. You can't do that with a context broker, particularly if the context broker is distributing where it's getting its information from. Within the Q parameter, you have got a wide range of ways you can split up your data. Obviously, you've got your less than, greater than, less than or equal to, greater than or equal to, fine, whatever. But the ones which are of more interest for advanced operations are the ones in the bottom half of the query. It is possible to query on regexes if you've got simple strings, or if you have an array of strings and you want to do a regex, an object within it, you can do a tilde equals followed by the necessary regex pattern. If you have got a numerical value, you can quite easily request for things within the range. So the if you look at query 2 and query 3 on that list on the right hand side, they are actually equivalents. One is saying looking for temperature equal to or greater than 20 and equal to or less than 25, or a capacity of less than 10. And the line below is saying temperature within a range of 20 to 25. And then you can see from the syntax for the third line, it's shorter, it's easier to get hold of. Now, if you look at the line below where you've got the address square bracket city, that would be looking for a sub-attribute within an object. And you notice that in this particular case, I have put the full URL encoded value for Dusseldorf, because this is looking for a direct string. This is where things start getting tricky if you start doing queries on local languages. This is where it might be, because obviously you might not have Dusseldorf capitalized with a D. You might not have Dusseldorf with an, or want to check, have I got an umlaut in there? If you want to do tricks like that, use the collation. Dots is a range, and then the AND operation is a comma. So, for example, the first example is looking for speed greater than 50, RPM greater than 3000, and it must be brand Mercedes. The OR operation obviously is just the OR bar operator, and you can see, particularly looking at the first example, that where there is ambiguity on the ordering of the operators, you can use bracket notation to make sure that these are done in the right order. So the first one is saying speed greater than 50 or RPM 3000 and Mercedes, and you can work out that that's going to work. If for whatever reason it's not the case, not doing what you'd expect, it's probably the easiest way to get things to work properly is to add in the additional brackets. Q is using Q properly is the key to using a context broker properly. But of course, there is a possibility, if you correctly set up your geoproperties as geoproperties, to be able to do the GeoQ parameters. Now, the obvious thing which needs to be done for any geoquery is that there needs to be a coordinates. Coordinates is usually going to be a single point, but there's nothing wrong with making it a polygon, which would be obviously an array of points, or indeed a multi-polygon, I think is supported, which would be an array of points. Coordinates use this square bracket notation. Once again, if you were having difficulties for whatever reason, you may need to URL encode the square brackets. As I said, it's not a problem when typically when services are talking to the context broker. It's more a case of when I'm testing it from the command line, that if it's not working, then it's because I didn't do the URL encoding properly. This is another reason for using tools like Postman rather than making curl requests directly, is that generally it'll get it right. Now within GeoQ, any supported geometry is required, because obviously there's no difference between the coordinates of a line string and the coordinates of a polygon, because they're both an array of locations. So that is necessary, and the obvious and the geoproperty itself by default is location, but other geoproperties are supported. So for example, observation space, where a device is looking at, is one of the defined terms in the core context. The other geo thing which is defined the core context is operation space, so the area covered by a device as opposed to the area viewed by a device. They're two different things. Those are the standard names, but vast majority you're going to use location. Location is very common, and it does the usual operations. So either near, beyond a certain distance, near, inside a certain distance, or within, contains, intersects, equals, disjoint, or overlaps. The temporal Cue parameters we saw briefly, but this is just to confirm what the various parameters for temporal are. Again, you can add in Q here as well, but this is just to make sure that when you're doing the temporal information, you get the time slot of your choice. Time at and end time at. End time at is only useful if you're doing between. Is any date time. So you can see there that you've got these ISO 8601 dates, which is the easiest way to get the information. You can do before, between, or after. Similar to the geoquery, you can have observed at is the default, like location is the default, but you could have additional ISO 8601 dates, which you could add in as additional subparameters if necessary, like, I don't know, tested at, let's say. Now, by default, the observed at property of a property is a non-reified sub-attribute, which is fancy words for saying it's just observed at followed by the date itself, but as a string. But if you want to cover in any additional time property, that would be just an ordinary property. So it would have a type and it would have a value, as opposed to just being a straight string. Connecting data providers. Right, so now we are trying to deal with data sharing, data space scenarios. There are multiple ways you can split up your data, but this is one which you should read the question and have a short think about what the answers are. So imagine this scenario. You've got a farm with pigs and cows, fine, and they're tracked by animal collars, and not only the farm, but a veterinary practice has got records about the same pigs and cows. So, you know, this cow is currently in calf. This cow is is currently injured or whatever, and you want to have a weather service providing detailed weather conditions on the farm. First question to ask yourself when you are doing a distributed system like the proposals for I4 Trust is you must ask yourself, in this scenario, who holds the data? Who are the data providers? And in this case, what data does the farmer him or herself actually own? And what data are they getting in from elsewhere in the data space? What are they purchasing? Now, if you're going to start distributing your data across multiple systems, then you need to have common data models. So what common data models should be used in this scenario? Am I permitted to copy data over from the veterinary practice, for example, or do I actually have to access it and refer to their data externally? Is it a case where it's a pull operation and I regularly poll for the data and get hold of it? So you've got to work out where is the data going to lie within your context broker, and how can you ensure that you are referring to the same entity? So this is where ideally you're using the same URN. Within this scenario, there are already several common data models. Go over to smartdatamodels.org, see if there's a model which you can build on. Not saying it's got everything you want. It's just saying that people out there are already using animal as a data model with certain attributes. When you saw the demo, you saw things like phenological condition or whatever. This is already in use in real life scenarios, so it's a good name to use. As far as your the fields on your farm are concerned, there's another standard model here called agriparcel, which is a lump of land. You can use that to try and push your model your fields in your example to be able to use a common setup. Regarding devices, there are a growing number of data models around devices, whether it could be a multi-device model or just a device, or it's a specific thing like, I don't know, a temperature sensor. There are alternative providers of context data mappings. For example, the iot.schema.org will also give you information on devices. It really doesn't matter which one you're using, more so that you are using a data model which is available publicly. One thing you need to remember is that for data exchange to work properly, your at context file should be on a public server, and it should say, okay, what I'm calling, I don't know, heart rate is really one of these. So you can be pretty certain that when you want to use this data, you know that's what a heart rate really is. If not only are there data models in specific domains, like in this case agri-food, there are also data models split into cross-domain. So weather is common in just as common in smart cities as it is in tourism or is in agriculture. So the weather data model is one which is in fairly common use. In this particular simple scenario, where we want to get the animal data from our vet, or some of the animal data from our vet, so we want to augment our context data with additional data from elsewhere, and weather observed is going to be used by the weather service, and we want to get that from them as well. Following the standard animal model, we've got a series of attributes. Now, as I said, you may be lucky and you may find that the ID of your entity is common. However, you may not. And in this particular case, you are an NGSI-LD animal is just what I'm using. Maybe my vet has already got different ID for the for each individual animal, or we can't, or maybe we can't do the request directly on ID for whatever reason. If that's the case, you'll need some sort of common shared attribute which you can use to get hold of the to identify that this cow really is Twilight. In this case, there is actually a legal ID. You may well find that is usable in smart city solutions, for example. And some of my attributes are going to come, as I said, phenological condition or reproductive condition directly from my my vet. For the weather conditions, now animal itself does not have a weather condition. You think about it, there is no way that a cow is raining. So you need to be careful here that within the located at usually points to an angry parcel, by the way, as opposed to the location, which is where the cow actually is. You can add in additional property of, in this case, property of relationship for convenience, because I want to make some sort of calculations based on, is my cow more productive in wet weather, or should I be bringing my cows in from the field because I would have a higher milk production because something's happening or the temperature is wrong. So what I've done here is that the weather conditions are being added in as a property of the relationship. Why? Because we want to associate the weather conditions with the animal somehow. If all we needed was to occasionally get hold of the information about the state right now, I could just have located at as an agri-parcel and then retrieve the weather conditions direct from agri-parcel. That would be doable as well. But there's nothing wrong in setting up your system with data in the right place for you. Obviously, the attributes, which is the data model, should be the ones which are the data I really want to share. But the properties, the extended stuff, which you wouldn't get in the key values, could also include useful stuff within my system. So I know that it's currently raining on Twilight. So maybe we need to have actuating endpoint. So we could, in this particular case, we could have no, this one's the subscription endpoint, so the other way around. So let's say I have on my cow an attribute called refresh vet data. Whenever I do a patch onto that particular attribute, and I'm saying I want to refresh my vet's data for phenological condition and reproductive condition, that would then be a change of state, update change of state. I could, at that point, I could have a subscription which is monitoring this refresh vet data attribute, and it would. You can see from the type of the subscription, I've got. I'm watching the animal ID. I'm watching I'm watching filling. I don't know why I'm watching filling. I should be watching the legal ID and the refresh ID, and I'm just asking for key values. Now, this is then sending it to an endpoint in the veterinary practice. The veterinary practice would then retrieve the data that's necessary. So you've got the fact that I want XYZ. It knows that it's me because this would be veterinary practice / whatever my ID for them is. It knows that I want to get the data, and it could then do an upsert back into the farmer's context broker. So in this case, what we're doing is we're doing a pull into my context broker of data from the vet's context broker. I could, if we have common IDs, I could more easily federate the data and just say, okay, we've got a common ID for Twilight the cow. So can you give me, I can say that, phenological condition and reproductive condition are elements which are pullable from elsewhere. You may, or in this particular case, because I'm talking about trying to put together two clunky systems which aren't totally in sync, you may need to do some business logic within the endpoint to do expansion compaction. So you could change, you could change legal ID to, I don't know, cow's identification number or whatever it is within the vet system, so that they could actually work out what one of these really is. But remember, we've agreed that the long names for these attributes are the same. That's the important point here. So what they're dealing with internally is frankly their problem, not yours. But you can actually do a conversion if necessary. We're agreeing on the long names. So that's one way you can do this to get hold of the data. But there's multiple ways you can do that. You could, as I said, you could use registrations to get hold of data, or you could do something like the following. You could use looking at the agriparcel model, and let's say for whatever reason field 1 is not unique. Again, I'm going for the difficult ways of doing it, because the easy ways are just add a registration. So we haven't got a globally shared identifier. What I'm going to need to do in this case is, because in my field, I'm calling it field 1, but I have there is already a well-defined attribute within the agriparcel model called related source. And in this case, related source is defined as an array of objects. And you can see here that in my related source, I could say, well, actually, the URN which I want to be getting is the URN for, in this case, weather 001, weather station whatever, is closest to this this particular field. So the agriparcel itself is able to hold the mapping between my ID and their ID in this particular case, and so I can make my request. At that point, fine, I can make my request. I can update my weather conditions within the agriparcel. As you can see, what I could do here is, because I'm able to get that information on the context broker from the context broker's field, I can just say, okay, I would like to do, say, an update on that. So I'd like to get hold of the latest data, and you can subscribe to the changes to say, again, this is using the an attribute as a subscription trigger. You can say, okay, here's I would like an update of data, and it will because the weather station has got a subscription on saying, okay, whenever someone asks for an updated data, give them the following. It will then give me back my weather. And of course, my end of the data space will then have to do the change and update the system. Usable or ontologically correct? I reckon we're all realists here, and we do realize that if you've got the world's best ontology for your entities, if it's not usable, then it's not a valid model. So, as I said, strictly speaking, there is no weather conditions on the animal, because strictly speaking, twilight the cow is not raining. However, you can navigate the knowledge graph if necessary. As I said, we can just strictly keep located clean, just saying this is what the location is at. But it really, really depends on your use case. If I were to determine, do cows lie down in the rain? In other words, I need to have on my cow a location, which I can then use to track whether it's moving or not, and a raining weather condition. I would be better off having those in the same entity. It would be possible to make queries onto your weather conditions if absolutely necessary, but it would be an awful lot easier to just duplicate the data on the entity, and you can reuse as necessary. A bit more data storage required. Your sub attributes, whether they're usable for other people, if they were to expand your data set, is another way of looking at it. So, as I said, if you are trying to push data into a system, typically you would use the batch operation, which is a post entity operations upsert, which means that you can deal with that changing multiple parts of the system at once. Particularly useful if you're trying to do things like linking data. So, for example, what happens internally with the IoT agents is that the both the device and the entity the device is linked to are updated simultaneously, and you have this provided by attribute. It should be noted that at the moment, registration can be used for either federated environments or actuations, but not both. This has been clarified in the latest changes to the ETSI specification. But if you have a proper federation, it means that you're happy to share all your data, which means in this case, the vet would be happy to be updated by the farm and vice versa. There are support of both of these is going to be more strictly defined in the latest definition. The summary as of today, but this will change in a couple of months. As of today, if you want a proper federation, go off and use Scorpio. That's one of its main use cases. Scorpio is excellent for the heavyweight federated environments. For actuations, Orion-LD does actuations, but that is like trying to turn on your water sprinkler by making a request. But you should remember that you can also use subscriptions for actuation, as indeed we showed for the example of getting data from the vet. You can actually use a subscription on the context broker. You have a something listening and go off and do something. So remember that true federation is something which does require a higher degree of trust than typically done for the I4 trust system. All of this comes to the conclusion that what you're actually trying to do is you're trying to get context, the state of the system. And if you can get more information about the system through either devices giving you data or registered services giving you data, or other members of a data space giving you data, you've got a better understanding of how the world works, and then your business logic will be able to make better decisions, smarter decisions in your smart system to actually change the state of the system and get better value out of having joined the data space, having got the devices in the field or whatever. So that is part 2 of the system, advanced parts of context brokers. At this point, I can pop over to the Q&A and see what questions we've got. Right, so question 1. You can put some more questions on whilst I'm reading. Did I get it right? Will modified at be automatically updated by the context broker when changing an entity? Yes. Modified at is an internal system attribute, and it is somewhere defined in the, I think it's 250 pages of the NGSI specification, that whenever an update changes, it will change the modified at of that attribute. So if you don't provide observed at yourself, you can always use modified at. But if you're trying to use temporal, observed at is the default, because observed at is when something happened, whereas modified at is merely when did the context broker update itself locally. So has that clarified that one? Any further questions whilst we're at it? We've got another 5-10 minutes at most, or are you all going to go off and work on your context brokers? If there's no further questions today, I'll be continuing on this vein. I think it's tomorrow. So I'll leave you to I'll leave you to digest what we've done, and I hope you see you all tomorrow. So thank you very much. And in answer to Pierre's direct message, the answer is yes. Oh, there's a question. Okay, so we've got another question here. Why I4 Trust cannot represent a solution for implementing a federation environment? Define the word federation is the answer. The definition at the moment for what is called a direct federation in context brokers is a very high trust environment. Federation is basically one great big happy context broker pushed across multiple instances. So it avoid the existing federated term is saying security is not really going to be a problem here. What the iShare part of i4 Trust is dealing with is distributed trust. So in which case I'm a little bit my context broker needs to remain a little bit suspicious of your context broker, because I may or may not give you what you want, dependent on what your security status is. Now, it has been recognized that there are multiple scenarios which registrations need to deal with. These range from the friendly full trust federation through to I don't want to hold any data myself, but I want to pass all my requests to someone over there, to I prefer my data, but your data will do if I haven't got it, to I want to get everything done by a third party, and effectively they are a proxy for my context broker. And on top of that, the registrant may or may not do all things which a context broker needs to do. If you look at actuation of devices, they can typically patch one attribute. They can't. They won't offer subscriptions, for example. So this is where federation, or proper true, big boy federation, is not the only way you can put context brokers together. And for data spaces, when we're talking about data spaces, we want to have different degrees of trust, or be able to, or context brokers need to be able to error handle different degrees of trust, put it that way. So this is why what I would say is true sort of mush together federation is not what I for trust, or not what is not the problem that iShare deals with. And the main issue as far as context brokers are concerned is that there needs to be a certain series of rules in place, common rules in place, so that error handling when I can't do something is handled appropriately. So does that answer that question? I see there's something else on the chat. Okay, any further questions on the Q&A? Because I nearly missed that one, Angelo, sorry. I don't know if I think you've got the same viewpoint on the chat than I have. It's got like it's on 3 different tabs. If you're not careful, you miss the tabs in question. So I think we're just coming up to the hour now. So in that case, as I said, if you've got any question, any further questions, just ping me on LinkedIn once you've worked out what question you need to ask. Okay, in which case I will see those of you who are still interested on the same time tomorrow then. Thank you very much.